All right, this is page 6. You should have finished this in class. If it is not complete, go ahead and finish it and then turn over to page 7. Okay, this is page 7, and I wrote the formula we're going to use at the top of the page. I'm going to do number 18. We're going to do it together, and then you'll do 15, 16, and 17 on your own. So, I have this information. I have a sequence, and I've been given the n. So, I'm going to need to figure out A1. Well, the n, it's right here, 20. And it'll be different for each one. And the D, so I know that A1 is my first term in the list. So right here, negative 17. The D is what you're adding over and over and over and over again. So some of them you'll be able to just look at and know, adding or subtracting. Some of them you can just look at and know. This one's a little tougher, so I'm going to say negative. You take the second term and subtract it from the first term. So negative 25 minus negative 17 is a negative 8. So my D is a negative 8. Now I'm going to take the information that I've collected and I'm going to say, oops, can't see that anymore, A1, negative 17, plus, parenthesis, N, I know that's a 20, minus 1, oh Lord, minus 1, times D is negative 8. Type this in your calculator, and when you do, you should get negative 100 and, Lord, I cannot write it early, negative 169. Okay, so that means that if I drew 20 blanks with these numbers in them, like I wrote these numbers in them, and I did 20 of those, the 20th blank, because that's what I found, would be negative 169. So I need you to do 15, 16, and 17 on your own using my example. And then down here, we're going to do number 20 together, and then you'll do 19 and 18, 18 on your own. So I need to give, it says graph the first 5 terms of the sequence. Well, I need some coordinates. So my first term is a negative 7, like right here, number 1. So I'm just going to write 2, 3, 4, and 5. Okay, my second number in the list is a negative 4. Third is a negative 1. Fourth is a 2. All right. I need to figure out the fifth one. It's not there. So you're going to have to figure out the fifth one in each of these. So the fifth one, I need to figure out what I'm adding over and over again. So I'm going to take the second, negative 4, and I'm going to subtract the first. Negative 4 minus negative 7 is a positive 3. So that means I'm adding 3 every time. So 2 plus 3 is a 5. Now we're just going to graph it. And remember that each of your graphs should make a straight line if you've done it right. I did this one because the grid is weird. It's counting by 1s right and left, but it's counting by 2s when you go up and down. So just graph it the best you can. I'm going to go over 1 and down 7, over 2, down 4, over 3, 1 would be about right there, over 4, up 2, over 5, up 5. And there's my line. Okay, so you do the same thing Find the first 5 terms for 18 and 19. When you're done, turn over to the next page. All right, this is page 8. We have been doing arithmetic sequences where we were adding over and over and over. Now, we're going to do geometric sequences. And a geometric sequence is a list of numbers that goes from one term to the next by always multiplying the same value. So I'm just going to multiply the same number over and over and over again. The number that we multiply by over and over again, its fancy math name is a common ratio. To find the common ratio, because it's harder with multiplication than it is with the division or with addition, you take your second term, A2, and you divide it by your first term. Okay, so let's practice. Find the common ratio for the following geometric sequence. So I'm just going to take my second term, and I'm going to divide it by my first term, is 4. That means that 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So that's the number I'm multiplying over and over and over again. This next one's weird. So we will have fractions and we will have decimals with geometric sequences. So I'm going to take my second term, negative 121, and I'm going to divide it by negative 242. When I divide those in my calculator, I get 1/2 or 0.5. I think it's easier to type in 0.5. So that means that each of these terms are going to be multiplied by 0.5 as it goes on and on and on. If it gets bigger as it goes, it means I'm using like a normal whole number. If it gets smaller as it goes, you're going to have a decimal or a fraction. So, are these geometric sequences? Well, let's check and see. Let me figure out what we're multiplying by. So let's do 15 divided by 5. That's a 3. 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. So yes, I use the same number over and over and over. All right, let's try the next one. I'm going to say second term, 20 divided by 25, first term. That gives me 0.8. So 25 times 0.8 is 20. Perfect. 20 times 0.8 is 16. So no, because that's not going to work. 0.8 does not work over and over again. Let's check this one. Negative 28. So divide the second one by the first one. You always got to put the second one on top. And I get negative 0.5. So 56 times negative 0.5 is negative 28. Check. Negative 28 times negative, my pen's not writing very good, negative 0.5 is 14. 14 times negative 0.5 is negative 7. So yes, this one works. All right. This one's pretty easy. I know what do you multiply by 1 to get a 5? It's 5. 1 times 5 is 5. Check. 5 times 5 is 25. 25 times 5 is 125. So yes, this one is a sequence. All right, we're just going to write out our information like we did for our arithmetic sequences. So we know that each of these numbers in our sequence, we call them all terms. 7 is our first term. And because we don't want to have to write the word term over and over and over, we give them short little names. This guy's A1, this guy's A2, A3, A4, and A5. And then you could go on and on to A bajillion. Okay? So I'm going to make that our A1. We know that is a 7. All right? Then the number that we multiply over and over and over again, we call that our common ratio. So 14 divided by 7 is a 2, so I'm multiplying by 2 every time. So R is a 2, and then the N is what you're looking for, and you have to get told that. So the same way with our arithmetic sequences, like it's easy to find the 4th term, it's not so easy to find the 80th term. So this is the same thing. I can just look at this and tell you the 4th term is a 56, but if I want to know the 80th term, I'm not going to multiply this 80 times. I'm going to use a formula. The formula when you're doing multiplication is A1 times R and then N minus 1. These little guys are exponents, okay? You've got to use exponents in your calculator. On your calculator, this is the exponent button you'll use. So it could say your A1 is a 3, and then your R is a 6, and then you'll hit this button right here, and it'll bump it up to your N. Say it's a 12, and then you'll do your minus 1. Okay? We're going to do these 2 problems together, and then I'll be done. So A1, our formula, times R, exponent N minus 1. So find the 5th term in the geometric sequence if A1 is 3, N is 5, and R is 4. So A1, R, N minus 1. Okay, so A1 is 3. So let's erase that and put in a 3. R is 4. I'm going to erase the R and put in a 3. Nope, put in a 4. And then the N is 5. So let's erase the N and put in a 5. When you type that in your calculator, you will get 768. So the 5th term in this sequence would be 768. Because we are multiplying, your answers are usually very big numbers. Okay. Number 2, find the 8th term in the geometric sequence. So we have just been given the sequence. So first we need to find our A1, our R, and our N. Well, A1 is the first term, 5. Okay, R is what we're multiplying over and over. So if I do 20 second term divided by first term, I get a 4. So it means I'm multiplying 4 over and over. So R is 4. N is what I'm looking for. You got to read the words. Find the 8th term. So I'm looking for the 8th one. So, all right, I see my A1. I'm going to erase it, and I'm going to put my 5 in, because that's what I found. See my R, I'm going to erase it, and I'm going to put my 4 in, because that's what I found. I see my N, I'm going to erase it, I'm going to put my 8 in. I would like for you to tell me what the answer is. Thank you.